Welcome to The Explainer. Today we're jumping right into something truly fascinating. We're taking an entirely impartial look at a highly structured mathematical perspective on physics by exploring Alireza G.M. Nari's framework of algebraic physics. Now, this model does something really unique. It views the cosmos not as a random collection of mysterious invisible forces, but as a highly detailed, mechanically perfect clockwork machine. It's just a completely different lens through which to view the universe, and we're going to break it down today, gear by gear. Here is our roadmap for today's explainer. 1. The clockwork universe. 2. The mother equation. 3. Normity's table balance. 4. Proving Earth's gravity. And finally, 5. Zero pressure extremes. So let's start right at the beginning. Section 1. The clockwork universe. No theories, only algebra. Okay, let's dive into this. To really wrap our heads around this framework, we actually have to completely discard the idea of invisible pulling forces. The source material relies purely on first-degree algebraic equations that are based on observed planetary behavior. In classical physics, we tend to think of gravity as this sort of magical, invisible pull, right? But in Nari's model, the gravity that is keeping you in your seat right this very second is strictly an algebraic output of Earth's orbital speed, its rotation, and its geometric distortion under pressure. There is absolutely no magic here, only mechanics. Moving on to Section 2, the mother equation and the universal benchmark. If you want to understand a clockwork system, you absolutely need to find the primary gear. It's the benchmark from which everything else calculates its timing. And according to the source material, that primary gear is exactly this number, 2,608,971.3 kilometers. In this framework, this specific number represents the precise length of just one single degree of Earth's annual orbit around the Sun. So, what does this all mean? Well, that number is the core of what Nari calls the mother equation. He posits this specific distance as the universal baseline. Think of it like an anchor that scales and calculates the physics of the entire solar system. Literally, every calculation of acceleration, gravity, and density for the other planets loops perfectly back to this foundational, 1-degree geometric slice of Earth's journey. Section 3. Normity's table and balance. The systemic output. Now, what's really interesting about this is exactly how that benchmark equation is applied to the rest of the planetary gears to prove a systemic balance. Notice the relationship here between gravitational pressure and systemic density. The framework argues for what it calls an acceleration mirror equation, basically a split in a planet's acceleration. For a slow-rotating rocky planet like Earth, a smaller portion of its acceleration is spent on its daily axial spin. Because of this, exactly half of the remaining pressure manifests directly as its density. So for instance, Earth's gravity of 9.8 divided by 2 gives a density metric of 4.9. In this model, density isn't just some random trait, it is a direct mathematical mirror of acceleration. And when we zoom out to look at the whole system, we see the numerical proof of balance. According to the Normity's table, the Sun's gravitational baseline is calculated at 76.16 degrees. Now, if you sum up the gravity of all the planets, you get exactly 58 degrees. Subtract 58 from the Sun's 76.16, and you are left with 18.16 degrees. And the sources claim this leftover 18.16 perfectly matches the combined pressure calculated for all the moons, comets, and cosmic debris in the system. It's like a giant puzzle where the equation balances perfectly. The Sun provides the base pressure, and it gets fractured and distributed flawlessly across the entire system. Section 4. Proving Earth's gravity, the geometric distortion. Let's zoom back in mechanically on our own planet for a minute. The framework actually offers multiple mathematical paths to calculate gravity. Let's look at the third path, which focuses on geometric distortion. The texts lay out these fascinating step-by-step mechanical proofs. First, Earth's equatorial speed of 111.6 kilometers per degree is multiplied by 360 to get a circumference of 40,176 kilometers. Second, and this is key, because Earth is spinning under pressure, it's not a perfect sphere, right? It distorts. The framework quantifies the specific distortion as a stress angle of 0.00000068. Multiplying the circumference by this stress angle gives an active pressure value. And finally, you multiply that value by the 360 degrees of the planet. So the crucial point is, when you complete that final step, this purely geometric and algebraic process loops flawlessly back to the globally recognized metric of 9.8 for Earth's gravity. It arrives at the exact same destination we all know, but it does it entirely through the mechanics of a planet's physical distortion under speed and pressure, rather than treating gravity as this separate, attractive force. Which leads us to a really fascinating concept within the model, the algebraic zip code. Since every planet experiences a different level of geometric stress, no planet is a flawlessly perfect circle. Therefore, standard Euclidean pi doesn't perfectly apply to physical planets in motion. By adding Earth's specific stress angle to standard pi, Nari calculates a highly specific, unique number. It means every celestial body effectively has its own customized pi, a sort of cosmic fingerprint or algebraic zip code, proving that mathematics literally has to adapt to physical distortion. Section 5, Zero Pressure Extremes, Black Holes and Neutron Stars. So let's see how this builds when we apply this clockwork algebra to the absolute most violent and extreme phenomena in the galaxy. The framework poses a really interesting question for us. If gravity is just a distribution of pressure, what happens mechanically when that pressure drops to absolute zero? Well, Nari's model addresses this by surprisingly applying Bernoulli's principle, the exact same physics that explain airplane lift, directly to the vacuum of space. The sources contrast these two extreme states purely through this algebraic lens. First, a black hole is described as a pure pressure vacuum, a literal zero-pressure environment created after a massive star collapses. It acts kind of like a severe pressure drop in a pipe, violently pulling matter in just to compensate for the vacuum. But then, on the exact opposite end of the spectrum, you have a neutron star. Now, according to that acceleration mirror equation we discussed earlier, a neutron star has zero axial rotation. Because absolutely none of its acceleration is spent on spinning, 100% of that mechanical force is converted into absolute crushing density. And this brilliantly illustrates the mechanics at play. To fill that absolute vacuum of a black hole, the mechanical compensation is just staggering. The framework claims matter is actually drawn in at neutrino speed, which the source material specifically clocks at 60 nanoseconds faster than the speed of light. This incredibly violent rush of matter to balance the zero-pressure extreme is, according to this model, the very mechanism that births new galaxies. So, we've explored the mother equation, the Narmades table, and algebraic proofs from Earth's gravity all the way out to black holes. And it really leaves us with this final provocative thought. If gravity and density are truly just algebraic outputs of geometry and speed, how does that shift our entire understanding of reality? It definitely challenges us to look up at the night sky and ponder a universe driven entirely by measurable gears, perfectly balanced equations, and physical pressure, rather than relying on unseen forces.